Welcome to the deep dive. Today we're getting our hands dirty, you could say. We're looking at smart agri.
Right. It's a fascinating piece of tech tackling a really huge problem, losing crops to disease, especially for small farmers.
Exactly. And the twist here, the thing we really want to unpack, is how smart agri helps diagnose these diseases. We're talking potato, wheat, rice, without needing the internet. It's a completely offline system.
Which is critical, right? Because most AI tools, they rely on the cloud. And if
Oh.
you're a farmer somewhere with patchy or non-existent connectivity, well, those tools are useless. Smart Agri aims to fix that.
Okay, let's get into that because complex machine learning, especially for images, that usually means big servers, lots of processing power. How on earth do you run that effectively on just a phone, completely offline?
Yeah, that's the core challenge they tackled. And it really comes down to keeping everything local. They use two main technologies. First, Flutter.
Okay, Flutter for the app interface. Makes sense, cross-platform.
Exactly. Build once, run on Android and iOS. Efficient. But the real powerhouse is TensorFlow Lite, TFlow.
Ah, TensorFlow Lite. So that's the on-device machine learning part.
Precisely. It's designed to run these complex models directly on the phone, no cloud needed. It does all the image classification, the disease spotting right there.
So no sending data up, waiting for a response,
Mm-hmm.
which, like you said, could take forever in a bad signal area or just not work at all. What are the sort of practical upsides for the farmer using that?
Oh, they're huge. First, obviously, no network dependency. It works anywhere, anytime, 100% offline.
That's a big one.
Definitely. Second, speed. The latency is super low. We're talking maybe 220 to 350 milliseconds to analyze an image.
Wow, so basically instant feedback. Snap a picture, get an answer.
Pretty much. And third, really important is data privacy. The images, the results. It all stays on the user's device, stored locally using SQLite. Nothing gets uploaded.
That's quite a package. Offline, fast, private. But okay, the tech dot running models like MobileNet v3, EfficientNet, they're usually pretty big. How do they shrink a model down to, I think the source said like 4.2 megabytes? That's tiny.
Yeah, it is tiny, and that's maybe the most technically impressive part. It involves conversion and something called quantization.
Quantization, break that down a bit.
Okay, so think of it like this. You train the big, complex model on a powerful computer, right? Then you use a tool, the T-Flight converter, to sort of simplify it. Quantization basically reduces the precision of the numbers the model uses. Instead of, say, highly detailed 32-bit numbers, it uses simpler 8-bit ones.
Like making a really efficient thumbnail of the original model.
That's a great way to put it, yeah. You lose a tiny bit of detail maybe, but you save a massive amount of space, down to that 4.2 megs. And crucially, you don't lose much diagnostic power.
Which means it can run on even pretty basic phones,
Yeah.
right? Huge for accessibility. Okay, so walk me through the user experience. Farmer sees a dodgy-looking leaf. Then what?
Super simple. They open the app, take a picture of the leaf. The app automatically pre-processes it, resizes it to the standard 224 by 224 pixels the model expects.
Right.
Then T-Flight kicks in, runs the analysis locally, again, less than half a second, and boom. The app shows the likely disease name, a confidence score like 96% sure it's late blight, and even some basic treatment advice.
But how reliable are those results after that, squishing down process, the quantization?
Yeah.
Did accuracy take a big hit?
That's the key question, isn't it? But the results look really solid. The paper reported, potato accuracy at 96.8%, wheat at 95.2%, rice 94.7%. So yeah, very high accuracy. Even with the compressed model, it works.
That is impressive. So the bottom line here is Smart Agri successfully shifts sophisticated analysis away from the cloud directly into the hands of the farmer. No internet needed. Fast, private, reliable knowledge.
Exactly. It empowers the farmer right where they are. And, looking ahead, the source mentions some really interesting future plans that build on this offline idea.
Oh, yeah. Like what?
Well, they're planning to add explainable AI, specifically something called GradCam, still running locally.
GradCam, that shows why the AI made a decision, right? Like a heat map on the image.
Precisely. So the farmer doesn't just get a name, they can actually see which part of the leaf image the AI focused on to make that diagnosis. Builds trust, helps confirm the result, all offline.
That's cool. Anything else?
Yeah, and this one's maybe even more radical. They're talking about updating the models on the device, not over the air, but physically, using things like SD cards or USB drives to deliver updated disease models.
Wow. So like physically distributing knowledge updates, completely bypassing the network.
Exactly. Which really makes you wonder, how else could that model, physical non-network knowledge transfer, how could that change technology access in other remote or disconnected areas? Not just farming, but, education, healthcare.
Hmm. High-tech knowledge delivered on a thumb drive. That is definitely something to think about. Okay, that's our deep dive for today. Thanks for joining us.
See you next time.